The journey of physics began with understanding motion. Ancient humans observed the movement of stars, planets, and objects around them. But it was Isaac Newton who created a mathematical framework that explained motion on Earth and in space. Newton discovered that objects follow predictable rules. A force can change motion. Objects resist changes in their movement. And every action produces an equal and opposite reaction. These simple laws explained falling objects, the movement of planets, the operation of machines, and much of the mechanical world around us. Physics is the human attempt to understand the rules that control everything that exists, from the smallest particles hidden inside atoms, to the largest structures in the universe containing billions of galaxies. Every star, every planet, every living creature, every thought inside our minds, follows the same fundamental laws of nature. Physics is the search for those laws. It is the story of how simple principles create the incredible complexity of reality. Gravity is one of the most familiar forces in nature. It keeps our feet on the ground. It holds the moon around Earth. And it controls the movement of galaxies. Newton described gravity as a force between masses. But centuries later, Einstein revealed a deeper picture. Gravity is not simply a pulling force. Gravity is the bending of space and time itself. Mass tells spacetime how to curve. And curved spacetime tells matter how to move. Electricity and magnetism were once thought to be separate mysteries. But experiments revealed that they are connected. A changing electric field creates magnetism. A changing magnetic field creates electricity. Together they form electromagnetism. This discovery changed civilization forever. It gave us generators, computers, communication systems, and the technology that connects the modern world. Light itself is an electromagnetic wave traveling through space. Thermodynamics studies energy and how it changes form. Energy cannot be created or destroyed. It can only transform from one form into another. Heat can become motion. Motion can become electricity. And energy flows from organized states toward more disordered states. This idea is called entropy. Entropy explains why time appears to move in one direction, why a broken glass does not naturally rebuild itself, and why the universe has an arrow of time. At the beginning of the 20th century, physics changed completely. Albert Einstein showed that space and time are not separate. They are connected into a single structure called spacetime. Time is not the same everywhere. A person moving extremely fast experiences time differently from someone standing still. Gravity itself can slow the passage of time. Near a black hole, time behaves in ways that challenge our everyday understanding. Relativity transformed our view of reality. When scientists looked deeper into matter, they discovered a completely different universe. The quantum world. At extremely small scales, nature does not behave like the everyday world. Particles can act like waves. Objects can exist in multiple possible states. And measurement itself becomes part of the process. Quantum mechanics revealed that reality at the smallest level is governed by probabilities, not certainty. The universe is far stranger than human intuition suggests. Quantum mechanics was only the beginning. Modern physics describes reality using quantum fields. According to this view, particles are not tiny solid objects. They are vibrations in invisible fields that exist throughout the universe. The Standard Model describes the known fundamental particles. Quarks create protons and neutrons. Leptons include electrons and neutrinos. Photons carry electromagnetic force. Gluons carry the strong nuclear force. And the Higgs field gives particles their mass. This is one of humanity's most successful scientific theories. Inside every atom is a powerful world. The nucleus contains protons and neutrons held together by the strong nuclear force. When nuclei split, enormous amounts of energy are released. This process is called nuclear fission. When small nuclei combine, even greater energy can be produced. This is nuclear fusion, the same process that powers stars. Every atom of carbon in our bodies, every oxygen atom we breathe, was created through cosmic nuclear reactions inside ancient stars. Physics also asks questions about the entire universe. How did the universe begin? How do stars live and die? How are galaxies formed? The universe began billions of years ago from an extremely hot and dense state. Since then, space itself has expanded. Stars created the elements needed for planets and life. But many cosmic mysteries remain. Dark matter, dark energy, and the ultimate fate of the universe. Despite incredible progress, physics is not complete. The biggest challenge is combining quantum mechanics with gravity. The theories that explain the very small and the very large do not fully agree. Scientists search for a theory of quantum gravity. Some explore string theory. Others explore new ideas about space and time itself. The universe still contains unanswered questions. What is dark matter? What is dark energy? Why does anything exist at all? And are there deeper laws waiting to be discovered? Physics is not only a collection of equations. It is humanity's attempt to understand existence itself. From falling apples to distant galaxies. From tiny particles to the birth of the universe. Every discovery reveals new questions. The more we learn about reality, the more mysterious it becomes. Physics is the story of curiosity, the story of exploration, and the endless journey to understand the universe we call home.